We'll begin this section by just looking at the definition of an exponential function. An exponential function is of the following form. F of x is equal to ax, where a is any number greater than 0, and we also have that a is not equal to 1. Here we say that the number a is the base, and x is going to be our input value to our function. Before we look at an example, let's go ahead and note the following. If a was equal to 0, or a was equal to 1, then our exponentials would look like the following function. In both cases, what we see here is defining our exponentials using one of these a values defines a constant function. We will not consider these types of constant functions to be exponential functions because they're not going to behave like the rest of the exponential functions. All right, so let's go ahead and evaluate the following. Let f of x be defined to be 2 raised to the x. What we want to do is we want to find f evaluated at 5. In part B, we'll find f evaluated at the square root of 2. And in part C, we'll find f evaluated at -1/2. So in this example, we're going to be using Mathematica. I have a separate video where I go over this problem in Mathematica, but let me go ahead and show you what we computed using Mathematica. In this first one, this is equal to 2 raised to the 5th, which is equal to 32. And the second one, this is going to be equal to 2 raised to the square root of 2, which is approximately 2.665. And then the last one, this is going to be equal to 2 raised to the -1/2, which is going to be equivalent to, it's going to be approximately 0.7071. Again, check the Mathematica video, which is separated from this video, and it goes over this computation. To end this section, let's go ahead and see why we won't allow our base to be less than 0. We'll be looking at an example. Suppose we're given a function f of x, which is defined to be -2 raised to the x. If we evaluate this function at a 1/2, then this is going to be equal to a -2 raised to the 1/2. This is equivalent to the square root of -2, which is equivalent to 2i. This function evaluated at 1/2 therefore gives us a complex number. We won't be too concerned about complex numbers in this course, and so we won't really consider this function at all, though this is a well-defined function that appears in other areas of mathematics.